Yo, you didn't expect another devlog so soon, did you? Yeah boys, I'm on the grind. I'm really excited to talk with you about the latest updates to I don't know, game engine. After getting the bare minimum for a working renderer in the last devlog, I wanted to add an extra feature, textures. When I first heard about textures, I thought it's a 3D only thing, because a texture was a thing that wrapped around the cube. It turned out that a texture is just an image, and that's it, working in 2D and 3D. Well, that is a lot, because we will be able to render everything to our screen. To render a texture, you first need to get, yes, another buffer. This one contains the information about the image you've uploaded. OpenGL doesn't implement this buffer in its API, but I used another library, stbimage, to make my life a little easier. And if anyone asks if I know what is happening in this function, then I will reply with a big no. Proud to be a software engineer. The next step to adding textures is communicating to OpenGL which portion of the texture I want to render. You can imagine that it works really similar to vertex buffers. But can't the program just render the whole texture? Yes it can, but manually setting the borders of the textures allows us to use stuff like sprite sheets. The only thing missing is tweaking the GLSL file so it renders the quad based on the texture and not the color, and now we finally render. I don't wanna talk about it. Let's just move to another texture. And that another feature is the entity component system. It is not a graphic term, finally, but it is a game programming pattern. It doesn't add any feature to the game, but with that, adding features will be easier. Are you getting it now? Great, so how do we implement that? If you ever worked in Unity, you've seen ECS. The basic idea of this pattern is that you have components that represent different areas of the game. Rendering, position, physics. These components are sort of like Legos that you can use to build stuff, aka game objects. It's useful because now those game objects aren't 1000 lines long classes. They only need to have references to the components used by them, and that's it. Easy. Well, it wasn't as easy for me at the start. You can go really deep with ECS, but I didn't know that yet. I just read an article after an article talking about this pattern. My biggest problem was that I had so much information, but I didn't know where to start. After a couple of days of research and trying things out, I settled on probably the simplest implementation. I just implemented components that described different areas of the game, and a game object that had methods for adding, deleting and choosing components. That's it, no caching, no data locality. In my eyes, I just needed a simple system that I can expand in the future, if I would need to. Next on our list is batch rendering. If you ever started learning graphics programming, you probably only used vertex buffers for position. Color and textures were defined by a shader program. So to render a quad, you need to give the position to the vertex buffer and define color and stuff in the shader. Then you just push everything to the GPU and your job is done. It's a simple solution, but it has a big flaw. We are now rendering 1 or 2 objects on the scene, but every game has at least 1000 objects on the screen at all times. Multiply that by the fact that the objects need to be rendered every frame, and the data pushing to the GPU starts to be really expensive. But we can do something much better. First of all, we actually don't have to split position and other vertex data. You can put everything you want in your vertex buffer and it will still work if you define your vertex structure to OpenGL. That means that we can push the data to the GPU from one source and not two. And if we can technically use vertices buffers for storing whatever data we want, why don't we only use one buffer to render a large chunk of data? That would speed up the game a lot, because instead of pushing 1000 different chunks of data to the GPU, we just push one big boy and that's enough. If you didn't catch it by now, I just described how batch rendering works. Implementing batching is pretty straightforward. To get batching working, I made a method in my renderer that would render a wall with dimensions defined by the user. I'm not sure that games use this approach, but I know how batching works, so if I need a different implementation, I'm gonna be able to hopefully easily change it. When I was writing batch code, I thought of something really cool. If we abstracted buffers to custom classes, we can probably just get rid of them. We have components that define everything the renderer needs, so my plan was to have a renderer that can render geometry just by reading the data from the game object. No more vertex buffers, vertex arrays. Shaders will stay yet, but they will probably also be abstracted soon. Abstracting all of this stuff was surprisingly easy. Probably the hardest thing was dynamically creating vertices buffers. I'm pretty sure you can make a smart for loop system, and you would have to change manually only 7 indexes, but I don't think it is much of a time saver, so I just have 28 lines writing data to the buffer. Oh, and see those numbers here that are hard-coded? Yeah, it is not supposed to be like that. These indexes are for textural coordinates. You can hard-code them like that 97% of the time, because you normally use the whole image for the texture, but it doesn't work with sprite sheets. And guess what I will be implementing in the next devlog?